Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will revisit the use of macros in new applications by reviewing two videos made in 2023. So what kind of macros are there? We have single line, where your code is all in a line. Multi-line, where the macro contains several lines of code. Macro functions, where the macro returns a value. In some of our recent videos, we have used macros, but this will be the first video in which we go into macros in detail and explain what exactly they are and what you can do with them. Inside PowerBasic, a macro is a powerful text substitution construct that, as I have said, can be used in three ways. We can have a single-line macro, a multi-line macro, or a macro function. A macro generates no executable code unless it is actually referenced. Therefore, you can set your macros up in an include file quite safely. So let's create some macros and show how they are used. If we demonstrate first of all this single-line macro. What we've done here is we've created a macro called mpy. As my own personal naming convention, I tend to precede the name of the macro with the letter M. This is to indicate later on in the code, and especially where someone else is looking at my code, that this is indeed a macro. So what we've done here is we've used the macro keyword followed by the name of our macro, mpy. And we're making it equal to the value of pi to quite a number of decimal places. What we're doing here is setting up our pi as a constant. As you will see here, the pi value has at the end of the numbers two hash signs. This is indicating to PowerBasic that the number we are providing is to be used as an extended format. This will allow 18 significant digits, which should be more than enough for your use of pi. Now that we've defined our single line macro, giving a value to the mpy, how can we use this in the code? What we have on screen now is a message to send the value of pi to our log. So you'll see in here we have referenced mpy. When you go to compile your application, the text mpy is replaced with the actual value of pi. For example, this piece of text. This keeps your code quite clean and succinct. We're using the str$ command to turn this numerical value into a string. We have used the optional parameter, 18, to say we want this to 18 significant digits. If we try running the code now, we will see it prints out 18 significant digits for the value of pi. Using a macro in this way allows you to effectively extend the language. This can be easily demonstrated by another use of a single-line macro. What we've put on screen is macro mrelease package equals macro. It may take you a moment to get your head around just what exactly we've done here. When you attempt to compile your code, any evidence of the mrelease package will be replaced by the word macro. So how can we actually use this? Say for example we wanted to store two pieces of information on this particular piece of software. We wanted to store the build version and the version number. So we're using the mrelease package followed by the word build version equals alpha build. Now as you'll note, we haven't done any declaration of build version or for that matter ver number. But when the application compiles, the mrelease package will be replaced as a piece of text with the word macro. So this is effectively extending your language to have anything you wish to put into a macro. So how would we reference that in the code? If we wanted to send this to our log, we can put a piece of text out saying release build version equals, and then just use the word build version, as this is going to be already set up with the value alpha build, and the ver number is going to come out with our version number. If we run that code now, we'll see those details appearing on our log. So it doesn't take long to realize you can use this construct to extend the language type you can use within PowerBasic. So having looked at this single line macro, what can we do with multi-line macros? Say for example, in our code we wanted to set up a local variable, in this case a string variable called strdata. And we want to set a default value to that string variable to be a comma delimited list of 5 numbers. This could well be something that you'll do in your applications on a regular basis, and you may prepare several variables with the same default values to be changed later on in the code. So is there an easier way of using a macro to set these default values up for you? We'll now use a macro, which is a multi-line macro, to set up this construct for you. And this is the construct we're going to be doing. We're going to call our macro mPrepFormat. And looking at the code here, it appears to be taking a parameter, str variable. But unlike functions and subroutines, you'll see the type of this is not declared. It's not showing as str variable as string. The reason for this is a straight substitution. Whatever we pass in as a parameter is going to be used inside the macro. So the 2 lines of code we have within this macro are first of all to declare str variable as a string. In this case, the variable is not actually called str variable, this is a substitution. Whatever we pass in on the parameter list is going to be substituted for the declaration of the variable. And then we're going to make whatever that variable is equal to our comma delimited list of 5 values. So let's try that out in the code. So we will first comment out where we put the lines in normally. And we will now put in our single line macro, mPrepFormat, containing the name of the variable we wish to first of all declare and secondly populate. And we will send the value of that variable out to our log. If we try running the code now, we will see we get strdata equals and the 5 comma delimited numbers appearing on the log. So what this single line of code has done is it has declared the variable you have specified and it has populated it with a default value. All done in a single line of code in your application. This becomes particularly useful if you're doing a number of different variables, all to be prepared in the same way. For example, we're now going to prepare 3 additional variables, data2, data3 and data4. We're going to set data4 with a different format, so we'll set up a different macro to perform that one. For this new macro, we're passing 2 parameters rather than 1. The first parameter is the variable we wish to do something with, and the second parameter is the data we're going to be putting into that variable. As you can see in the code, we're using local and whatever the variable is to declare it. We're then populating that variable with the data that's come in on our parameters. So if we add these additional variables to our output log and then run the application, we'll see the values come out quite happily. So if you have a large number of variables to declare and populate with a default value, this gives you a very easy and fast way of doing it in your code. When PowerBasic compiles, it will expand the macros out into the code. So let's say we want to do something more complex. We want to do something with a user-defined type. So let's declare a user-defined type at the beginning of our code. So here we have a simple UDT called storage. It's going to contain 3 elements, a date string, a value string, and another value string. Ideally, before you reference data within a user-defined type in your code, you may want to prepare it with a default value, for example empty length strings, or in this case, a date in the date field. So we're going to prepare a new macro, and we'll call this one prep_udt. We will give it 2 parameters. The first parameter is the user-defined type we wish to actually declare and populate, and the second variable is the data we want to put into one of the string fields. And we will then print out both the date and the value from that user-defined type. So here is the skeleton of our macro, with the 2 parameters. The first being a user-defined type, and the second being a string. As before, these are straight substitutions. Whatever comes in on the parameters is going to be substituted for what we're about to do. So first of all, we will declare our user-defined type as a useStorage, and then we can begin to populate the values within that type. So we're putting in the current date from date dollar into the str_date element. We're putting the input value passed on the parameters list into the value field, and we're setting the other value field to be an empty length string. There are some limitations with macros which is worth mentioning here. When you're preparing one of these user-defined types, I quite often use the prefix command to save a wee bit of typing. However, you can't use the prefix command within a macro, because you're effectively doing something that's not on a single line. It will generate an error. If you also use the underline as a line folding command, this will also generate an error. However, these are fairly small limitations to what you can do with macros. So now that we've actually prepared our macro, let's try running it. And there is a user-defined type. The two elements are coming out to a log quite happily, the first being the date dollar value, and the second being the value we passed on the parameters. So if you're preparing a number of user-defined types based on this premise, you can use this command again on a differently named type. We're now creating one called uTomorrow, and we're putting new data and the date into this. If we run that code now, we'll see this runs quite happily. Macros can be a useful tool to make your coding less tedious, much in the same way as we use libraries of functions and subroutines. So in order to get the best out of our macros, we're going to create a library to hold them. I've created a library file called macro library as an include file, and all the macros we created are included in this file. So we're going to reference this include file at the beginning of our code, and we will move this single line macro into our library. So now that we have referenced this library in our code, we can now go ahead and compile and run our application. And our application runs quite happily, displaying the release build version and the version number. The advantage of macros is if they are not referenced in the main bulk of your code, then they add nothing to the size of your executable, as these are text substitutions performed before the actual compilation. So what we're going to look at now are macro functions themselves. So first, we need a problem which our macro is going to be the solution. So let's say, for example, we have two strings of data, and we want to fold both of these strings in together so that the characters within these two strings are interleaved. So we have created some local variables to allow us to do this. A data1 string and a data2 string. The data1 string contains 4 letters, A, B, C, and D. The data2 string contains 4 numbers, 1, 2, 3, and 4. We want to create a macro function whose job it is to take the first character from the first variable and add on the first character from the second variable, and then work through each character interleaving as it goes. And the return from this macro should be the entire new interleaved string. And the output from this macro we will store in our output1 variable, which is a string. So our macro is going to be called foldString and will take 2 parameters, data1 and data2. And the output from this macro will populate our output1 variable. So let's go into our library and we will create this new macro function. As we did in the previous video, we're going to be passing the 2 parameters inside the brackets. But as this is a macro, we don't need to declare the type of the variable, as this is merely a text substitution process. So if we were to perform this task without a macro, we could probably use a for next loop. So that's what we're going to be using inside our new macro. We're going to step through each of the characters in the data1 variable, 1 character at a time. And we're going to use the mid $ command to pull out 1 character from the first variable and 1 character from the second. And we're building up our output variable. So we'll declare these variables in our function. However, with macros, there is one additional command we will need to put in place. as this macro could be used several times within the same function or subroutine in your code. We don't want to have a collision with the declaration of the local variables. Therefore, we need to use the macro temp command to get around that problem. The macro temp command makes sure that the declaration of long R and str output is unique. It does this by adding a 4-character number onto the end of each of these variables. So when this code is replaced within the body of your code, it will be replaced as long R 0001 for the first time it is used. If we call this macro later on in the same function, it will appear as long R 0002, and everything else within this macro function will have that defined. So anytime we refer to long R, it will be replaced with the long R and the version number of the variable. So for the first iteration, it will be 1, for the second 2, and so on. So regardless of how many times you call this macro within a function, there will be no collision with local variable declarations and no problems with compilation. So as we can see in the code, the output variable is the return of our macro function, which is then returned to the calling function. So we will now output that value to our log and attempt to run our application. So our application has now run, and the output variable contains A1, B2, C3, D4. So we have successfully taken two variables and interleaved the string constants into a new output variable. And we've outputted that to our log so we can see the value. This macro function is a very straightforward and simple function, but it does illustrate what we can do with a macro function. So to illustrate that calling this macro function would have no problems with the declaration of variables, let's call it once more within the same function. But this time we're going to reverse the parameters. We have declared a second output variable, output2, and we're populating that by calling our fold string macro with the parameters reversed, with data2 as the first parameter and data1 as the second parameter. If we run our code now, it will compile quite cleanly and will give us the output reversed. We now have 1a, 2b, 3c, and 4d in our output variable. So we have successfully created a macro function to return a value, in this case a string. You can of course return numerical values as well as string values. So what other kinds of macros could we actually create? One of the things you may wish to use within your application is the use of the randomize command. The randomize command is used to seed the random number generator. This seed value can be used to give you a predictable list of pseudo-random numbers. If you want your randomize routines to return values as random as possible, you want to seed it with a value that changes every time. The timer command can be used to do this. But what we're going to do now is we're going to create a small macro as a function to return a randomized seed. And we're going to call this macro random seed. So let's go back into our library and we'll create this new macro function. So this macro is going to return a dword, a numerical value which we can use to seed our random number generator. This macro is going to contain a piece of code which was originally created by Steve Hutchison, one of the titans of the PowerBasic forum, who is sadly no longer with us. So as we did before, we're going to use macrotemp to ensure there are no collisions with the variables we're going to declare. So our var variable is going to be a dword. This is what our macro is going to return. And we're going to be using a bit of inline assembly here to return the value, efficiently and very quickly. Our first command is rdtsc. This reads the current value of the processor's timestamp counter into one of the registers of the processor. In this case, we're particularly interested in the EAX register. Our second command is a swap command. This reverses the byte order within the EAX register. And our third and final command is to copy the data within that register to the variable we have already declared, our dword var variable. This move command quite efficiently moves the value within that register into the declared variable. This is one of the strengths of inline assembler within PowerBasic. You can pass information from registers straight into your variable, and this var variable is what we're returning to the calling function. So when we compile, any reference to the mRandom seed will be replaced by these lines of code. So if we try running the code now, we should get back a nice large dword value. And there is our value on screen. So while we're sending this value to the screen, we would normally use it as the parameter of the randomize command, as you can see on screen now. Calling randomize and followed by our macro. We can attempt to compile that and it will compile quite cleanly. And this will give us a random number. So if we declare a local variable called value, we set the value within that variable using the random command to give us a value between 1 and 20. We can then push that value out to our log. And the value we get is 16. Since the random number generator has already been seeded, we can make a call to the random command once more and get a different value. So first time we're getting 19 and then we're getting 3. So this gives you a very easy way of getting a pseudo-random number. So what we've seen today is we have touched on the use of macros within your application. We started with a single line macro to store constants. We can also use the macro to create our own custom command words to store constant values within the code for build versions. We can also use our macros to prepare variables, both declaring and populating them. And finally, we touched on the ability of creating user-defined types and prepping them within our macro. We've also created some macro functions. These macro functions are set up in an include library with the previous macro functions. This include file can be called from any of your applications and will only add to the code of the executable should the macros be referenced within the body of your code. Macros are a very useful way to save tedious coding, much along the lines of using functions and subroutines in include files. Hopefully you'll find these approaches useful in your applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.